Hi and welcome to my latest YouTube video. This is actually a continuation of one of my previous videos on effect sizes. In that video I had covered the effect size and how to calculate it for correlation, for Kruskal-Wallis test and even chi-square. However, I had not covered ANOVA. So in this video I'm going to be showing you how to calculate the effect size for ANOVA. But before that I want to share a few words about the effect size. So as we are all aware, the p-value or the significance value tells us how likely your results occurred by chance or error. For example, a p-value of 0.05 indicates that if you carried out the same experiment 100 times, you would get a false positive about 5% of the time only. The p-value is useful in helping us reject or accept the hypothesis, but it does not tell us the extent of the difference between two or more groups. This is where Eta-Squared comes in. It measures the effect size of the difference for ANOVA. So let us now calculate it using SPSS or PSPP. I'm using PSPP here, but you can follow the same steps on SPSS as well. So let us say I want to compare marital status. Okay, I have multiple groups here. I have unmarried, married, and divorced and separated. And I want to compare that with the depression score of the respondents. So here we are dealing with a bunch of patients who are admitted in a hospital for cancer treatment. So let's compare them. For this, we first calculate ANOVA. We go to Analyze, Compare Means, one-way ANOVA, and I just click Reset. Ensure that marital status is in the factor section, and in the dependent variable I add the total depression score, which is a continuous variable. Click on descriptives, click on OK. So once I do get the results, I'll be able to interpret the Eta-Squared. So as you can see, there is a significant difference between the three groups. You can see that the ones who are married seem to have the lowest level of depression, 13.65. This is followed by those who are divorced or separated, whereas the unmarried, who are probably very young, all have the highest level of depression with 26.15. Now we also know that this result is statistically significant at a high level, because we see the significance value of 0.005, which is quite high. However, we do not have the Eta-Squared here. So Eta-Squared can be easily calculated by dividing the sum of squares for between groups with the total score. So I'll just show you how to do that with a calculator over here. So between groups, the sum of square is 1300.59, and we divide that by the total sum of squares, which is 5177.50, and the value we get is 0.251. So this is the Eta-Squared value. Now to interpret this value, I have a table over here. I leave the link in the description. As you can see, if it is a value between 0.00 and 0.01, it's negligible. 0.01 to 0.06, it's small. 0.06 to 0.14, it's medium, and 0.14 to 1 is large. So our value is 0.25, which is greater than 0.14, and we can say that there's a large effect. So the results are not only significant, but the effect, the difference is quite large, and the effect size is quite large. So this is a very important value to present when you're presenting your results. So I hope you found this video useful. I will leave the link to calculate the effect size for other statistical tests in the description. So that's it for now. Thanks for watching, and bye for now.